How do we train word embeddings? Let's look at that next. We can go ahead and take a large corpus of text. Wikipedia is such a large corpus and is used. When we do the huge amounts of training that Google and so on do, they will often use sort of all of the web. But let's just use, let's say, Wikipedia. And what we then do is we break Wikipedia into 7-word chunks, overlapping 7-word chunks. Okay, so we'll take something that says, let's say, the reason that Hitler invaded Poland was to someone. Okay, and so we're going to take 7-word chunks. So we're going to take 1, 2, 3, 4, 5, 6, 7. The reason that Hitler invaded Poland was, and then we're going to take another chunk, which is, let's say, so let's just kind of write that one down. The reason that Hitler invaded Poland, and then the next one is going to be reason that Hitler invaded Poland was to, and we just keep going. So for every article, we'll just break it apart into overlapping sets of 7 words. And then we're going to use each of those as a way to generate an input and an output. So what we do is that this becomes an X of the reason that invaded. This only has 6. I missed out on was here. That invaded Poland was, and the associated Y is going to be Hitler. Here, we're going to do the same sort of thing. This basically becomes the Y, and this becomes the X. So we're masking out the middle word, and we are trying to teach the neural network that we can feed in the X to the neural network, and we can get out the Y. So we can feed in reason that Hitler blank Poland was to, except you don't actually have the blank, and that we'll get out invaded. And we feed in massive numbers of these. Okay, but how do we feed them in? We feed them in via embedding. So we're going to actually feed in 6 words. X1, X2, X3, X4, X5, and X6. We're going to put these all through an embedding. Again, a key here is it's the same embedding. Okay? So we are using the same embedding matrix here. And this goes into then pretty simple neural network. Could be more complex, but it's normally not. And then this goes in to a big softmax. If our vocabulary is 10,000 big, then this is going to be a 10,000 output. So it's basically 6 words coming in, each of them coming through an embedding matrix first, through often a relatively simple neural network, and then we go to a softmax where we're saying what is the probability that each of these words could be the missing word. Training with this sample, training with this example, and we have many, 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 many examples. And eventually then we get an embedding matrix that, well, first we get to decide how wide is this embedding matrix. And in fact, if you look at many of these embedding matrices that exist out there for public consumption, you can get various widths of these, various sizes of the embedding matrix. So it might be 10,000 by 50, or it might be 10,000 by 100, or 10,000 by 150. As you can imagine, as the multidimensional space increases, it can represent more information, more fine-grained information, but it just is larger. So that is how these things get trained, and then they actually get published. So there is, for instance, Word2Vec, means word to vector, glove, where VE stands for something having to do with vector. And these are just downloadable embedding matrices. They provide you 2 things. They provide you the embedding matrix, And then they also provide you the dictionary. That is, what were the words, and crucially, what are their indexes, right? You need to know, right, because an embedding matrix, right, is going to be, let's say, 10K by 50. Well, what that really means is if you just take, for instance, dog, and dog happens to be 0, 1, 0, 0, 0, and a bunch of zeros, and you multiply that matrix, that vector, by this matrix, you are picking out a particular row from here. You're picking out, in fact, the second row. So in the embedding matrix, the first row is the embedding for the encoding for not present, the second for dog, the third for cat, and so on. So you need to know what this dictionary was and what the order is. So when you deal, for instance, with glove, you'll get not only the matrix, but you'll get that dog is 1 and cat is 2 and lion is 3, or whatever the values are. When you are dealing with words, you often, like almost always, will want to have an embedding matrix involved. And you often want to use a pre-initialized one.